Okay, this is number 3 from that sheet with the differential equations, and so this was what you were given, and you need to solve for y. So the first thing you're going to do is cross multiply with y dy on the left. And then you're going to take the integral of both sides, and you should get y to the 3 over 3 equals 2e to the x plus c. So I would recommend that before you start solving for c, why don't you get rid of that 3 in the denominator, and you can do that by multiplying everything by 3, and you'll get y cubed equals 6e to the x plus c. So you're not bothering to write 3c because that's just one more constant. So I'm going to put a little star here to remind us that that's where we stopped before we used our c. And the information that we were given, that y of 0 equals 2. That means when x equals 0, y equals 2. So I stopped here at y3, y to the third equals 6e to the x plus c. So now I'm going to replace y with 2, and I'm going to replace x with 0. So 2 cubed is 8. E to the 0 is 1. 1 times 6 is 6. Subtract 6 from both sides, and you get that c equals 2. So therefore, I'm going to go back to where I put the star, and instead of plus c, now I can write plus 2, and that was choice A. And I just wanted to talk for a minute about checks that you can actually do for this. So what we're saying is that the original function is this. Now you were also told that in the original function that when x is 0, y is 2. So if I substitute 0 in for x and 2 for y, it better be equal. Well, that means I made a mistake. So if I put 2 in for y, I'm going to get 8 equals e to the 0 is 1. 1 times 6 is 6, plus 2 is 8. So it checks. So that doesn't mean that it's always going to be 100% right, but at least it definitely, helps to confirm that I'm probably right. Okay, so I'm skipping number 4 because actually there was an error in number 4. You don't have to worry about that. I'm not sure what the typo is in there, but there's definitely something wrong, and that one does not work. So I'm going to go straight to number 5. So I don't know why I put this integral sign here when I started number 5. Sorry about that. Okay, so for number 5, this is what we have. There's no cross multiplying or anything, so we're just going to add an integral sign to both sides, and then we're going to get y squared over 2 equals 2x to the 2 over 2 plus c. Obviously, these 2's can cancel, so you get y squared over 2 equals x squared plus c. Just like in the other problem, I'm going to multiply everything by 2 to get rid of that denominator. That will give me y squared equals 2x squared plus c. And we actually don't have to solve for c, and we know this because we were not given an initial condition. However, this doesn't look like any of the choices, but if you subtract 2x squared from both sides, you'll see that that is choice C, because choice C says y squared minus 2x squared equals 0, so therefore C must equal 0. Not that you're asked for that, but that's why that would make sense. Okay, so this is number 6, and you were given all kinds of crazy information in the letter K, and it might seem like you're not sure what to do, but let's just do what we know how to do it, the things we do know, and then hopefully that will just lead us to our answer. I don't know if you noticed that I just changed the pen thickness to a little bit thicker, and I think it looks a lot better this way. Okay, so if we cross multiply, don't forget dy stays on the left. Now we have to move that x squared over to the right side because all x's have to be together. Okay, and then we're going to integrate each side. So before integrating, I'm going to rewrite the right side so that I'm all ready to take the antiderivative. And there's nothing here on the left side, so really there's a 1, isn't there? So the antiderivative of 1 is just going to be y. K is a constant, so that will just be k. X, negative 2 plus 1 is negative 1 over negative 1 plus c. So I'm going to rewrite that as negative k over x, because x to the negative 1 will bring it down to the bottom, plus c. Okay, so I'm going to move that to the next page. Okay, so we were given a bunch of information. Let's go back and look at that. So the first piece of information that we were given was that when x equals negative 1, y equals 4. When x equals negative 1, y equals 4. Okay, so I'm going to substitute those values into here. And I'm going to get 4 equals negative k over negative 1 plus c. That gives me 4 equals positive k plus c. I'm just going to box that for right now. Okay, now I'm going to make a little box here. Use some other information that I was given, such as the fact that when x equals 1, y equals 2. So I'm going to substitute these values into here, and I'm going to get 2 equals negative k over 1 plus c. So that means that 2 equals negative k plus c. So I now have two equations, and I don't know if you recall something called simultaneous equations from the trig class, which means that you have two unknowns and two equations you can solve. So I have an unknown of k and I have an unknown of c, so I'm going to put one right under the other. So I had 4 equals k plus c, and I had 2 equals negative k plus c. And when you combine these, you see that these cancel, and you get 6 equals 2c. So therefore we know that c equals 3. Okay, if c equals 3, then now I can solve for k, because I know that 4 equals k plus c. So 4 equals k plus 3. Subtract 3 from both sides, and I get 1 equals k. So now I know what c and k is, and the question is, when x is 2, what is y? So the original function was this. dy over dx equals k over x squared. And we found that the original was y equals negative k over x plus c. But now I know what k is, and now I know what c is. So now I can just say that y equals negative k, but k is 1, so negative 1 over x plus c, and c is 3. So that means this is my original function, and I'm supposed to find out what happens when x is 2. So when x is 2, I get y equals negative 1 over 2 plus 3. So a negative 1/2 plus 3 equals 2.5, also known as 5/2, and that was choice E. So I guess that's it.